So what we're going to talk about is slope. And all we're going to get through are the big ideas that are in section 5.3. Mostly, given where we are time-wise today, I want to get the formula for slope out to you and where you find it in problems. We'll do more next time with actually getting into maybe some of the solving for it stuff. And I also want to talk about why we talk about slope. So there's a lot of ideas happening here. Let's start with where it shows up in formulas. We've talked about this equation a little bit off and on. If an equation fits that format, this is the slope, the m. The thing about slope, and you may have seen this before, most students have, is that when we define slope, I don't want to use that tool. Let's use this one, the slope. We talk about it as the rise over the run. So if I were to draw a graph, boom. So there's my axis, and I've got my line on it. There it is. I want to look at how much it goes up and how much it goes over. That's my rise, and that's my run. So how fast am I getting bigger is what my slope represents. How fast am I increasing over time? Slope is ultimately some kind of rate. And we've seen that as we've talked about some of these story problems. So for example, we talked about somebody charges $30 per hour. So if I were to ask you to write a formula about how much money somebody's going to make, what would that formula look like? What would the function be? At $30 per hour, which is dirt cheap, grand scheme of things, for a skilled tradesman. So like we're not paying the plumber, we're paying the plumber's apprentice. So $30 an hour while he's there to do work. How do I write a formula that shows how much I got to pay the guy based on how many hours he's there? 30x. Of course, also you need to make sure there's that function notation part. So f of x equals. Not always.
Would you write like next to
An m?
No.
Oh, rise.
Other side, yeah.
Rise. Rise is how much up, run is how much side to side. So, that's my rate, isn't it? That's the rate. That's also my slope.
How's 30 rise over one?
That means for every I rise $30, so if this is my graph of how much money I'm making, I go up $30 per hour I run, per hour I go sideways. So whenever we're talking about how fast something is occurring, what the per item thing is, that's a sign we're talking about a slope. How much the line goes up or down based on how fast we're going left, right. So what we need to get through today is how to calculate slope given 2 points. We'll do the rest next time we meet. So here are a couple of points. We'll stay within our story problem. So let's say I get my bill from the plumber. They've come out, they've unclogged 2 toilets and fixed my garbage disposal. Well, that's not a bad day's work, right? And so they tell me that for that 7 hours, they're going to charge me $600. All right. A couple weeks later, we have some more problems. They say, well, we're going to have to replace your water heater. I have a water heater to replace, so that's fine, but I got to pay the guys to put it in, make sure everything works. It's not that bad of a job. So let's say 4 hours worth of work, and the bill comes to an even $500. That was horrible. Let's not be so greedy. Let's make it an even 300. There we go. Question, what's the slope? How much am I paying per hour to have them work for me versus how much am I paying them just to show up to cover gas and expenses and tools? Yes? That works as long as there's no like setup fee. Like if he's going to charge me $100 just to show up and then charge me per hour, that would work. But that's not going to happen here. So my formula looks like this. Slope is the difference in the two y's divided by the difference in the two x's. That'll tell me the actual rate. That'll tell me what I'm paying per hour. That'll tell me how fast that line goes up while they keep working, while they're on the clock. This is what everybody gets an hourly too. So let's see what we get. Let's put these into the formula and see what happens. My rate is going to be 600 minus 300 divided by 400 minus 7. Sorry, 4 minus 7. Now let me add some color so you guys can see where these numbers came from. Y2, Y1. And then my X2 and my X1. Are you hearing what? Yeah, there's a little scratchy noise from the tablet. So it sounds like when it's quiet in here. It's weird. All right, let's finish up the math. 300 divided by 3 puts me at a nice, neat 100. So in this case, my rate is going to be $100 per hour. True.
Would it be -3 times 4 minus 7? 4 minus 7 is -3. Which would get you to -3.
Oh! Okay. No, watch. You're absolutely right. Let me fix that. How did I do that? 3. Oh, yeah, here's what I did wrong. Doink. Oh, I did that all in one shot, didn't I? Okay. M equals... Sorry about that, guys. 300 minus 600 over 4 minus 7. There we go. That works. Doink. Okay, well, that was not an accident. No, I did that on purpose because that's the kind of mistake students often make. You get numbers flipped around, you lose your signs. So negative over negative becomes a positive 100. And that happens a lot. So you kind of got to watch out for that. Now, if I had flipped the numbers around, so I did 600 minus 300, then I would do 7 minus 4, and you still get to that rate of 100. But most of it's going to be tied in practicing that formula and getting used to your signs. The sign numbers are always where people trip with this. It's always where it gets hard and sticky and ugly. But as long as you follow the formula, you're not too bad. Let's knock out one more quick example with some smaller numbers, and then we're going to call it. Let's say I'm working with -2, 0, and I don't know, how about 5, -3? Shoot. Yeah. I mean, maybe not for this particular test, but ultimately, yeah, if I give you 2 data points, you should be able to do all kinds of fun stuff with it. Find me intercepts, draw me a graph from it. Just these 2 points has a lot of information buried in them. Heck, you could plot those 2 points on an axis. So you could put those points in there and then see where the line goes and do all kinds of cool stuff with it. Some of things like that, yeah. So anything we did in chapter 4 is fair game today. But let's get this example done. So m is equal to, now I'm going to do y2 minus y1, so -3 minus 0 over x2, 5, minus a -2. And this is where I mean signs are tricky. That's a plus now. So if I rewrite this, -3 minus 0 over 5 plus 2. That gives me -3 over 7, which I'm going to rewrite as -3/7. So that my negative is applied to the whole fraction. This means my line is going down. Positive slopes go up. So if you think about it, the more I work, the more I got to pay. Negative slopes are going down. Maybe this is like the value of my car. The longer I own it, the more the price drops, kind of things. Or value of baseball cards. The more we print, the less they're worth. So the more that are out there, the more the value goes down. So that'll be a negative slope. And what would the slope be if it didn't change? What do you guys think that slope's going to be? The value of a $100 bill is always $100. So what's the slope? How much is it changing? So the slope would be 0. 0 slope doesn't change. Positive slopes go up, negative go down.